Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Doppel Jr., your math tutor and an instructor of mathematics at the University of Liberia. So in today's lesson, we are going to look at derivatives of trigonometric inverse functions. But first, we want to derive all of the 6 derivatives of the trigonometric inverse functions. So now we know that an inverse function, a trig inverse function is of the form. So let's say y equals to sine inverse of x. Now, this sine inverse of x is not equal to sine of x is not equal to 1 over x, 1 over sine of x. So take note of that. This is sine inverse of x. This is not sine of x raised to the power minus 1. This one is sine of x raised to the power minus 1, which is 1 over sine of x. So take note of that. And we also know that if we want to get rid of an inverse function, if we have, for instance, we have y equals to sine inverse of x, we want to get rid of this inverse function, we take sine on both sides, because sine of x is just equals to x. So based upon that, we take sine on both sides. So we want to do it on this side. So we take sine of y, we take sine of y, then we say sine of sine inverse. Okay, sorry. So this is sine of sine inverse of x. Similarly, sine inverse of sine of x is also equals to x. So we can take sine on both sides. So what's going to happen? We have sine of y will now be equal to x. So we can apply implicit differentiation right here and find the derivative. So the derivative of sine of y, we know that is just equals to cos of y. But since y is the name of the function, we must attach y prime. The derivative of x is just 1. So let's solve for y prime. We divide this side by cos of y and divide this side by cos of y. So this and this cancel. Y prime is equal to 1 all over cos of y. But this is not the final answer that we need. We know that from the Pythagorean identity, cos square y plus sine square y equals to 1. So in order to find cos of y, we can make cos square y the subject. So this will now be 1 minus sine square y. And then we take the square root on both sides. So the square root cancel these 2, but the square root cannot cancel these 2 because you have 2 terms in it. So we'll have cos of y to be equal to the square root of 1 minus sine square y. So where's where we see cos of y, we're going to put the root of 1 minus sine square y. But we know that this sine square y can be rewritten as the root of 1 minus sine of y all square. What is sine of y from the beginning? Sine of y was just equal to x. So y prime is equal to 1 all over the square root of 1 minus x all square. Thus, d by dx, that is the derivative of sine inverse of x, is just equals to 1 all over the square root of 1 minus x squared. But what if we're considering a general form, considering that considering u to be a function. So we're going to say 1 all over 1 minus u squared times u prime. That is, if we differentiate the trigonometric inverse function like we did in the previous lesson on the trigonometric functions, when we differentiate the trig function, we must differentiate the angle. So when we differentiate the trig inverse function, we must also differentiate the angle, which is u.